Earth is our home, a vibrant planet teeming with life. We look up at the night sky and see stars, planets, and the vast expanse of the cosmos. Among these celestial bodies is Mars, our reddish neighbor. Mars has captivated our imaginations for centuries. It is a place of wonder, a potential second home for humanity. But what if this seemingly distant world held a hidden power, a force that could influence life on Earth as we know it? Mars is smaller than Earth and much farther away from the Sun. It might seem like Mars, with its thin atmosphere and dusty plains, couldn't possibly have any significant effect on our planet. However, the universe is full of surprises, and the laws of physics govern even the most subtle interactions between celestial objects. One such interaction lies in the realm of gravity, the invisible force that connects everything in the cosmos. Gravity is a fundamental force of nature. It's what keeps our feet on the ground and the moon in orbit around Earth. Every object in the universe, from the smallest atom to the largest star, exerts a gravitational pull on every other object. The strength of this pull depends on two things: the mass of the objects and the distance between them. The more massive an object is, the stronger its gravitational pull. The Sun, for example, holds all the planets in our solar system in orbit because of its immense mass. The closer objects are to each other, the stronger the gravitational force between them. This is why we feel Earth's gravity more strongly than the Sun's gravity, even though the Sun is much more massive. Now you might be wondering how Mars, a planet much smaller than Earth and millions of kilometers away, could possibly have any gravitational influence on us. The answer lies in the subtle dance of gravity over vast distances and immense periods. While Mars's gravitational pull on Earth is minuscule compared to the Sun's or even the Moon's, it's not non-existent. Imagine Earth and Mars as two dancers circling around a vast cosmic ballroom, the Sun. Earth, being closer and more massive, leads the dance. However, as Mars makes its own journey around the Sun, it exerts a small but persistent gravitational tug on Earth. This tug is not strong enough to pull Earth off its orbital path, but it can cause a slight wobble in Earth's orbit. Think of it like two people holding hands and spinning around. The person spinning faster and closer to the center will have a stronger pull, but the other person's weight will still cause a slight sway in their combined movement. In the same way, Mars's gravity gently tugs on Earth as they both orbit the Sun. This tug is most pronounced when Mars and Earth are closest to each other in their orbits, an event that occurs roughly every 2 years. While this gravitational dance between Earth and Mars has been occurring for billions of years, its potential impact on Earth's climate is a relatively recent area of scientific study. New research suggests that this subtle gravitational interplay could have a more significant effect on Earth's climate than previously thought. Section 4. Shifting orbits Earth's slow dance towards the Sun. Over vast cosmic timescales, Mars's gravitational influence could contribute to a subtle shift in Earth's orbit. This shift would be incredibly slow, happening over millions of years, but even a small change in Earth's distance from the Sun could have profound effects on our planet's climate. You see, Earth's distance from the Sun is not constant. Our planet's orbit is slightly elliptical, meaning it's not perfectly circular. This means that Earth is sometimes a bit closer to the Sun and sometimes a bit farther away. This variation in distance plays a role in Earth's seasons, but the overall average distance has remained relatively stable for millennia, allowing life to thrive. However, Mars's gravitational pull, even though it is small, could act as a gentle nudge over long periods, potentially causing Earth's orbit to become slightly more elliptical. This increased ellipticity could mean that Earth spends a slightly longer time farther from the Sun and a slightly shorter time closer to the Sun. While these changes might seem minuscule, even a small increase in the average distance between Earth and the Sun could have noticeable effects on Earth's climate over long periods. Section 5. A warming world. The climate connection. The Sun is the ultimate source of energy for Earth's climate system. The amount of solar radiation Earth receives depends on its distance from the Sun. Even a small change in this distance can alter the amount of solar energy reaching our planet, leading to climate changes over time. If Earth's orbit were to become more elliptical due to Mars's gravitational influence, and if Earth's average distance from the Sun were to increase slightly, our planet would receive less solar energy overall. This decrease in solar energy could lead to a global cooling effect. However, this cooling effect is counterbalanced by another factor: greenhouse gases. Human activities, such as burning fossil fuels, are releasing increasing amounts of greenhouse gases into the atmosphere. These gases trap heat and warm the planet. Recent scientific studies have shown a correlation between the cyclical variations in Earth's orbit, influenced by the gravitational pull of other planets like Mars, and periods of warming and cooling in Earth's history. While these orbital variations are natural and have occurred for billions of years, the current rate of warming we're experiencing is far more rapid than anything seen in the geological record. This accelerated warming trend is largely attributed to human-induced greenhouse gas emissions. Section 6. Feeling the heat impacts on daily life. The complex interplay between Mars's subtle gravitational influence on Earth's orbit and the much larger impact of human-induced greenhouse gas emissions presents a multifaceted challenge. While Mars's gravitational pull might seem like a minor player in the grand scheme of Earth's climate system, understanding its role is crucial for scientists studying long-term climate patterns and predicting future climate scenarios. The more immediate concern, however, is the accelerating rate of climate change driven by human activities. This human-induced climate change is already having observable effects on our planet, from rising sea levels and more frequent extreme weather events to shifts in plant and animal life cycles. These changes are impacting people's daily lives around the world. Coastal communities are facing increased risks from flooding and erosion. Farmers are grappling with changing growing seasons and more frequent droughts or floods. Human health is being affected by extreme heat waves and the spread of diseases. Addressing climate change requires a global effort to reduce greenhouse gas emissions and transition to cleaner sources of energy. It also requires adapting to the changes that are already underway. Section 7. The final word: our place in the cosmos. As we gaze up at the night sky and marvel at the wonders of the cosmos, it's essential to remember that we are part of a vast and interconnected system. The planets and stars might seem distant and inconsequential to our daily lives, but their subtle influences have shaped our planet and continue to play a role in the intricate web of life on Earth. While Mars's gravitational pull might be a gentle nudge in Earth's cosmic dance, it serves as a reminder of the interconnectedness of our solar system and the delicate balance that sustains life on our planet. It's a call to action to protect our pale blue dot, not just for ourselves, but for the countless generations that will follow. After all, Earth is the only home we know.